Hey guys, this is my YouTube channel and I am here to just give some thoughts on generative AI that is based on STA or STA that is based on generative AI or chat GPT. So what here it is that we are talking about the static timing analysis STA. It's latch timing. Latch, as we know, are the edge portions and the flip-flops portions are some others, as we know, like SR latches and SR flip-flops. So what is happening here is that suppose we are taking a buffer or an inverter. Buffer, the output is as it is as the input, but in inverter the output is inverted of its input. So what here it is that when two inputs are produced to an AND gate, the output will be entertained like such. But if suppose the same is with some buffer, then it is also the same. So these both are equivalent to each other. Similarly, talking about the STA flow, we get to the guarantee with an example that we are having some timing checks in timing analysis. Basically, in latch timing, we are working on setup checks and hold checks. This is like a just and snapshot or figure reason of how we entertain an STA in an SDC format, in an static design constraints format. So what is happening that our TML and our GLN, this is your homework to just introduce and get to know about what it is TML and GLN. When it is provided with some external environment of design, including clock definitions as an input, with a design verification analysis, we get to know through an STA these timing reports, including violating paths if extraction is done, is produced with an output. So what here it is that we used to get to know that to verify the design that is to be operated at a rated speed dVA in a Verilog or VHDL module or SPEF. The external environment and clock definitions as DC format as having as a static design constraints. The important aspect of STA is that entire region is analyzed once. So if you are working in an STA environment, we are having two types of environment. An STA, the static one, and one is the dynamic one, that is DTA. So if you are working in such an environment that you are using an MUX, we are producing an input with an AND gate, and that is going to a MUX. Suppose we are having 2:1 MUX, that are having one with an AND gate and other with an OR gate. This is having an output. So what's happening here is it is 2:2. This is 2:1 MUX, but it is having 4 inputs previous. So what is happening? It is calculating the previous input and providing the desired output. So this is having to verify the design to be uploaded at a rated speed. That design verification analysis in Verilog or VHDL module, or as it is in SPEF, that external environment and clock definitions are based on static design constants format. The important aspect of STA is that the entire region is analyzed only once. This is how about the inputs to desired output. It is analyzed for once a while, and required timing checks are performed for all possible paths and scenarios of the design. For all possible paths, as we know that your path is like as it is, and your scenarios are something like as such. So, with your path, your nodes, your wires, and all yours,